In this video, we will talk about solutions. The first and foremost thing that we should know about solutions is that it consists of a solute plus a solvent. Here, the solvent is our dissolving medium. Usually in General Chemistry 1 and General Chemistry 2, that is deionized water, very pure water. If you go to higher level chemistries, you'll have different solvent systems, but for most cases, in this class, it's going to be water. So, the solvent is going to be water. If that's the case, we will call that an aqueous solution, in which the solvent is water. Now, that's the dissolving medium. The thing you want to dissolve is the solute. Usually that's the particulate matter. So if we take this hypothetical example, if we weigh out 5 grams of sodium chloride and dump it in 100 mils of water, keeping it so that the final volume is still 100 milliliters of water, we will have an aqueous solution. Once again, solute plus solvent is equal to solution. Now the thing is, we have to determine some sort of concentration of that solution. Is that bottle of sodium chloride that I have now, salt dissolved in water, is it concentrated? Is it dilute? Okay, how do I measure that? Well, we have to attach a number to that that sort of designates how concentrated or how dilute that particular solution is. And to do that, we use the concentration term known as molarity. This is a very important point. Molarity is designated as moles per liter. Moles per liter. Now, in General Chemistry 2 and beyond, it's more specific than that. The technicality is that molarity is not only moles per liter, more specifically, it's moles of solute per liter of solution. So now, if we have a bottle of sodium chloride, which is nothing more than 5 grams dissolved in 100 mils, we can actually put a concentration to that bottle. So by doing that, again, remember molarity is big M, it stands for moles per liter. We have 5 grams of sodium chloride. We convert that to moles, and that is 0.0862 moles of sodium chloride. We divide it by the total volume in our solution, that's 100 mils. 100 mils is nothing more than 0.10 liters, and the concentration in our bottle of sodium chloride is 0.862 molar. The way we say it is 0.862 molar. 0.862 molar is the concentration of the sodium chloride. Sodium chloride is an ionic solid. One important thing here that you will see later on in the course is that ionic solids, when you dissolve them in water, they dissociate. They dissociate in water. This is called solvation. The water molecules actually sort of split the ions into their component parts. So water will solvate the sodium ion, water will solvate the chloride ion, and you have basically an electrolytic solution because these ions conduct electricity. Realize 2 important points here. Number 1, a solution is solute plus solvent. And for the most part in chemistry 1, the solvent will be water. And important point number 2 is that the concentration of that solution is going to be expressed in molarity. Molarity is moles over liter, more specifically moles of solute over liters of solution. Let's go over some practice problems involving the manipulation of this term molarity. This is taking concentrations and figuring out how much volume or how many grams are involved. In other words, these are solution stoichiometry problems. So our first problem is how many grams of solute would you use to prepare each of the following solutions? So let's look at this first solution here. We have 250 milliliters of 0.600 molar ethyl alcohol. So 0.600 molar is molarity, big M is molarity, and molarity is moles over liters, moles of solute over liters of solution. So an important thing to recognize here is that if I ask you to go make me a solution, there's 2 things you must retort back to me. You must say, well, hey, what is the concentration you want? That's number 1. And the second thing you should ask is how much, which is the volume. So to make a solution, pretty much it's like making a pie. So if I ask you to make a pie, you'll come back to me and say how much. Okay, so how many for 1 people or 1 person, 2 persons, or 10 people, and what type of pie. So in that same analogy speaking, if I ask you to make a solution, how much, so the volume, and what concentration of the chemical you want me to make of that solution. So two things are required to make a solution, and those two things are shown to us here. We need to do some stoichiometry to determine how many grams are in 250 mils of ethyl alcohol, whose concentration is 0.600 molar, which is 0.600 moles per liter. 250 milliliters is given to us in the problem. We'll highlight that in green. Converted that to liters. Recognize that big M, let's highlight that in green again, is the same thing as moles over liter. So 0.600 molar is 0.600 moles over liter. Having done that, translating what big M stands for, we can convert that moles of ethyl alcohol to grams. Again, let's be cognizant of our unit cancellation. The problem is asking for us to solve the problem in grams, and seeing that the mils cancel, the liters cancel, and the moles of ethyl alcohol cancel. We're left with grams of ethyl alcohol, and doing this on my calculator, I'm getting an answer of 6.91 grams of ethyl alcohol that is contained in 250 mLs of a bottle of ethyl alcohol whose concentration is 0.600 molar. How about this problem here? We have a bottle of boric acid, and the label on the bottle tells us it's 0.200 molar, which is moles per liter. And so we're going to take 167 milliliters out of that bottle, and the question is asking us how many grams of solute are in there. Pathway to get to the answer in grams. Remember, the question is asking us to solve this in grams. So 167 mils is what we're starting out with. So let's go ahead and highlight that in yellow. And that's what we start off with. We'll convert that to liter. We'll convert that to liters, knowing that 1 liter is 1,000 milliliters. And we know that 0.200 moles per liter is the same thing as 0.200 molar. And that allows us to cancel out the liters. And the moles of boric acid will cancel out with the moles of boric acid, as we recognize that 1 mole of boric acid is 61.87 grams of boric acid, getting those values for hydrogen, boron, and oxygen from the periodic table and summing them up. So canceling out all the units, we're left with grams. That's what the question asks us to put it in grams, and we're getting an answer to 3 sig figs, significant figures of 2.07 grams of boric acid. We'll highlight that in yellow. So we take out 167 milliliters out of this bottle, whose concentration is 0.200 molar. It's the same thing. Within that 167 milliliters is dissolved 2.07 grams of boric acid.